Hi everyone, we're going live now. Super exciting to be doing another AWS project with you all. It's Natasha from Nextwork here, and I can't wait to be doing part 4 of our cloud networking series today. So as usual, today I have my setup on my computer over here. We have the Nextwork community on the left-hand side of my screen. And as you can see on the right-hand side, I already have the project step-by-step guide up and running. But for today, I think what we're going to do is we're going to just learn how we can navigate to the project itself, because we've been getting a few questions about how do I find the project. And then we're going to get straight into the project step-by-step guide. Can't believe we're already at part 4 of the networking series, by the way. It feels like we only just started yesterday. So this is really, really cool. All right, so if you don't have access to the Nextwork community yet, this community is how you can get access to the step-by-step guide for this project, as well as the documentation templates, as well as a community where you can connect with other AWS students, ask questions, and also share your work as well, so we can help each other out and support each other in our journeys. Today, what's gonna happen is you're gonna come into your Nextwork community, and if you don't have access yet, the link to join is in the description box. And once you're in here, all you have to do is find a tab called All AWS Projects on the side over here. And when you click into that, you'll just have to find Project 15, Cloud Networking, launching VPC resources over here, and we'll click into this one. And here you are. You'll be able to find your project page, and you can click Start Your Project here to start straight away. So once you click on the link, you'll be able to see this page with the step-by-step instructions for this project. And how I usually recommend it is if you happen to have two monitors set up, you can have your step-by-step guide on one hand, on one monitor, and then your AWS console on the main one. That's how I usually like to set things up. But absolutely, you can always collapse your step-by-step guide into just the half screen mode as well, and you can still follow along completely fine, even if you were to split your screen half-half between your AWS console as well as the project step-by-step guide. But yeah, once you have the guide up and running, all you have to do is switch tabs over here to your AWS console, and we can get started straight away. So really, really exciting update with this week's project as well. If you haven't noticed with some of our older projects over the last week, we've done like a major update, like a major upgrade to a lot of our projects by including something in every single step that asks you questions about what you've done in this step, and then it will generate your project documentation for you. So what you would have remembered from some of our previous projects is you would have had to open a file on Canva, open it in a new tab, and while you're doing all of your projects, you'll be typing into a Canva file to update your documentation as you go. But now, all you have to do is stay within the project step-by-step guide, and as you see questions and as you see prompts to upload your screenshots, just follow those prompts, and when you're done with all of the different questions and all of the tasks in your step-by-step guide, you're going to see this very satisfying button at the very end of your guide that says mission accomplished. So this gray button is going to turn blue, and then you can get a step-by-step, you can get your project documentation generated for you straight away, just based off of all of your responses throughout this, throughout all of the questions and all of the prompts you're going to get. So you're going to see this magic happen in this live demo today, and absolutely you already have access to this. So if you were to click into this project as well, you'll be able to get access to all of this these new features as well. I'm really excited to crack into this project with you now. So shall we get started into the intro? All right, so you are at the very 4th AWS networking project now. So if you haven't done the first 3, you can absolutely still follow along today's project. It's just that you might find that some of the explanations are a little bit quick, are a little bit fast, because we do assume that you have done the first 3 already. The cool thing about this series is that every single project you are repeating what you've done already in the previous X number of projects before the current one. So, since we're on the 4th project, you'll be repeating the steps in the first 3. And I would highly recommend that you check out the first 3 if you ever feel like the explanations are a little bit fast. The links to the first 3 projects, they're all at the description box below as well. Awesome. Just wanted to say a quick hi and hello Hello and thank you to everyone in the chat as well. Udoak says hello. Abhishek says hello, Natasha. Amarul says, hey, Natasha, just wondering how many projects will you guys make or upload for the community? Wow, the total number of projects we're going to make. Honestly, that's still undefined for us. Like how we see it is we're going to keep on going, just keep on going every single week. It's going to be very, very hard for us to run out of topics, I'd say. The challenge probably more is like, how can we create even more projects for you every single week and make them even better? Absolutely, our roadmap of projects is ongoing. Like there's definitely no end date to that at the moment. I know it's a very vague answer, but truly, there's no finite number of projects we kind of have in our minds. We're gonna keep on making more. So you're gonna definitely keep on learning with Nixook as well. Smith has just joined. Did I miss anything? No, actually, we actually just started as well. So welcome, and I hope you enjoy. Alrighty. So in the first 3 networking projects, you've created an Amazon VPC. Amazing. A public subnet. Woohoo! An internet gateway. Hot damn, that's really cool. A route table, which is so good. A security group. Say what? You've created a network ACL, also called a network access control list. So the access control list will be this thing over here. Very nice. You've also created the private subnet, which is that blue thing over here. You've created a private route table, which is this one over here in this diagram. Use superstar. That is something that one of our top community members, Abdul, loves to say. Use superstar. And you have also created a private network ACL, which is this thing, this element over here. That's huge. So you have learned so much already in the first 3 networking projects in this series. And what else are we going to add to this series today? We're going to level up by launching resources into the VPC. So we have created the structure, we've created the architecture now, I would say. And at the end of the day, you can think of VPCs as kind of like a supporting role. It is the architecture or the way that our resources can talk to each other, can talk to the internet, can transfer data between each other. But at the end of the day, we really need to be launching resources into the VPC to really see it in action. Otherwise, all we're doing is kind of like setting up a skeleton and then there's like no meat on the bones. It's kind of how I think about it. So what we're going to do is we're going to kind of take that first step into like adding that meat on top of the bones that we've set up by launching resources in them. So in this project, we're going to get ready to, 1, launch an EC2 instance in the public subnet. So if you remember, the public subnet is this element over here at the bottom. And then we're also going to launch some resources and EC2 instance in the private subnet, which is this one over in the top. And then we're going to use the Amazon VPC's wizard to create VPCs at a lightning fast pace. So this third point doesn't add actually to our architecture diagram so far. This third point is more about how can you spin up this entire architecture in a very, very fast way. So you can do it at like in a second or so. I would say in a second. It reminds me a little bit of using CloudFormation and how you can spin up a lot of resources in just a few seconds by having a template set up. You can think of in this third step, the Amazon VPC wizard is going to produce very, very similar results. By defining a few key characteristics, a few key elements, you can spin up a whole new VPC and all of its components in just seconds. So I can't wait for you to check that out too. Okay. Wow, Amaru says, I can't wait for more projects. Me too, me too. We have so many cool things lined up. And Brenda says hello. Saying hello back, Brenda. Thanks for joining us today. All right. So as always, we're going to be choosing the high touch mode for today's project. And there are always 2 different modes that you can pick. So low touch is the mode that kind of leaves it up to you. The steps aren't exactly like click here, type this. It's more like here's the goal. Try giving it a go, see if you can do this. High touch mode, which is what we're doing today, gives you the step-by-step instructions for every single part. It's great for beginners. And I think I really do appreciate the level of detail in a high touch guide as well, which is why we always pick that for the lives. And yeah, with every single project, please delete all of your resources by the end, even if you don't finish the entire project. The reason for that is just so that you can avoid any costs. AWS billing can be a little bit sneaky sometimes where when you first launch something, it's like, oh, it's free. Like I didn't get charged for this. But then it's only when you leave it in your account and the charges rack up. Um, so absolutely, please delete all of your resources. Even if it means you might need to start over again the next day or the day after or the week after, it is much better than leaving it in your account and saying, yeah, I'll come back to this, and then letting it just slip from your mind and letting it rack up charges in the background. So with that, if you're ever stuck as well, or if you ever run into a bill, you're wanting some help, or you saw something cool that you want to share, let's chat about that in the Nextweek community. So students like you are already asking questions about this project, about the series, and about using AWS in general. I think every single question that gets asked in the community contributes to it and makes it an even better place. So please do come ask your questions in the Nextweek community, and you'll be surprised at just the amount of support and the number of students that have gone through very, very similar experiences as you. It's awesome. It's just such an awesome place. So hope to see you there. Okay, like I mentioned before, the new feature that we have today is kind of like a document generator. So we'll be using that. And in order to really see the results of that document generator, just make sure that you fill out all of the tasks in the project. So if you don't type in answers to all of the questions, if you don't upload all of the screenshots, you won't be able to get access to your documentation at the end. So you just have to make sure to fill out everything. Okay, now we're gonna get straight into it. As you might be very, very familiar by now, the first step is usually to repeat the steps of the previous project. So now we're going to set up the VPC basics by look at this whole list. We're going to set up a VPC, a subnet, internet gateway, the route table, security group, ACLs, and private resources as well. Such a big list, and you're going to crush it. We're all going to crush it together. Off we go. First things first is the VPC, as always. It is the foundation for our networking project. It represents our corner of the AWS world, and we're going to set one up right away. So how you do that is in your AWS console, let's head to the search bar over here at the top, and let's type in VPC like this. And let's click on VPC. Amazing. Perfect. And let's set up a new VPC. Saying hi back to View from Thailand and Tam as well. Hi, hello. All right, we're gonna click on Create VPC, and we're gonna choose VPC only in this resources to create option. We're gonna use VPC and more later, but for now, let's click on VPC only and let's build things from scratch. The name tag is gonna be very simple. We're gonna call it Nextwork VPC. And we're going to define the IPv4 CIDR to 10.0.0.0/16. Very nice. Now at the bottom here, we're going to click on Create VPC and we're all done. That was so fast. Just like that, our VPC is created. It's in the world now. And as a reminder, you can think of a VPC as like a city. If you were to think of your region, in my example, I'm in the Oregon region. If Oregon is like a huge country, you can think of your VPC as kind of like your own city where you can control all of your resources inside. You can control the traffic rules. You control the security. You control how things communicate with each other. A city is truly your city, or your VPC is where you get a lot of control over the network of all the resources that you decide to deploy in your AWS account. And that's why we're going to deploy EC2 instances later, so you can see that in action. But yes, what is a city if you don't have little neighborhoods or little, I guess, like subgroups within that VPC? So what we're going to do now is, oopsies, you can see that I actually still have my VPC from the previous project, which I should have deleted. I think this would have happened earlier today when I was just doing my final checks to make sure my project looks okay. But I'm going to quickly delete this VPC to avoid any confusion with some of the resources you're about to see, because this is what your VPC page should look like. You should just have one VPC, and it's called Nextweek VPC. And with that single VPC, we are going to create a subnet within it. So as I mentioned before, the subnet would be kind of like a little neighborhood inside. And let's create a subnet by just clicking on Create Subnet on the top right-hand corner and selecting Network VPC as the VPC ID. So what we're really saying is, hey AWS, I'm about to create a new little neighborhood, and can you just please make sure that neighborhood is within my city called Network VPC? And we can even name that neighborhood as well. So for now, let's give it a very, very generic name called Public 1. And then under availability zone, we're just going to select the first availability zone on the list. No big stresses here. This one's a very simple selection. It's not going to affect much. And if you're curious, the availability zone chooses the zone in which your subnet will reside, or you can just let Amazon choose one for you. But an availability zone is truly just a group of data centers that are really powering the resources that's being launched in your region. So for example, in my example, if I were to expand this, you can see that Oregon is actually split into 4 different availability zones. There's 2A, there's 2B, 2C, and 2D. So each of these availability zones are like clusters of data centers that's just sprinkled around the Oregon region. And when I'm really launching a resource in my VPC or in this region, what's happening is a server or like a physical server in a data center in one of these availability zones is creating that EC2 instance for me, and it's kind of like storing or hosting that EC2 instance for me. And all right, here, AWS is kind of reminding us, oh, by the way, since you want to create your subnet, your neighborhood in the Network VPC city, just a reminder, this is the range of all of the, oh, I should be zooming in a little bit more, shouldn't I? This is the range of all of the addresses that falls inside that city. So can you please make sure that neighborhood, the address for your neighborhood should be enclosed within that city. Just make sure that the IPv4 CIDR block is not going to be bigger than the IPv4 CIDR block that you've assigned to your VPC. And we're going to do exactly that. So our neighborhood is going to have a much smaller number of IP addresses inside. And as you can see here, I'm going to type in 10.0.0.0/24, and that is kind of like a block of IP addresses that I'm going to assign to that subnet. And this little helper text is telling me, oh yeah, having a CIDR block that ends in a /24 means you're assigning about 256 IP addresses to your subnet. If I were to change that to /16, look at that. That's 65.5 thousand IP addresses within your entire VPC. That's the size of your entire city. And then by choosing /24, I'm like, okay, out of the K's, like 25,000 like addresses, I'm just going to assign 256 to my subnet. So we've created a little neighborhood now within our city. All we have to do is click on Create Subnet over here, and we're ready. Look at that. Our subnet's all created. That was super, super fast. And what we have to do next, can you remember? Do you remember what we're going to do next after the subnet? So after we create the subnet, we also have to enable this special setting called Enable Auto-Assign Public IPv4 Addresses. So how you do that is you locate your subnet. So I'm going to find it here. Click on the checkbox next to that. And then under Actions, we're going to select Edit Subnet Settings right over here. And when you click on Edit Subnet Settings, you can also click on that button that says Enable Auto-Assign Public IPv4 Address. And then off you go. Click Save. Done. How good is that? Just like that, we've enabled a setting that makes sure that all the resources that get deployed into your subnet automatically have a public IPv4 address. It is such a good shortcut way to make sure that all of the resources in your subnet are public. It's the same as saying, okay, now that I've created this little neighborhood, I'm going to set up this system where every single building that gets built in my neighborhood is automatically public to the world. So it's automatically like something that can be accessible by the public. Anyone on the street can just walk in and just hang out in that place. If you don't have this setting turned on, what you'll be doing is you'll have to manually assign a public IPv4 address to make a resource public. We don't really want that because it is an extra like manual step. And in a public subnet, typically all the resources should be public and accessible by the internet, accessible to the internet. So that was awesome. And if you're wondering what's going to happen if a resource doesn't have that public IPv4 address, it's kind of like just having a private address or like a residential area in a city or in a neighborhood. You can think of the public resources as kind of like the shopping malls, the libraries, the schools, things where anyone from the public can just walk in. And then the private resources are kind of like your own home, your own apartment, something that's private. I don't think anyone from the public can just walk in and just like hang out in there. So that's kind of like the difference between public and private resources. And you can just kind of apply that kind of thinking or logic to like whether something should be accessible to the internet or not. So now that we have enabled that setting, what we're going to do next is we're going to create an internet gateway. So what we've created just now with the public subnet is a way for all of the resources in this subnet will be accessible to the internet if they have that address, but also our VPC currently doesn't actually have that connection to the internet yet. It's kind of like saying your neighborhood now has the ability to be seen to the internet, like they have the address for it, but then your VPC, the entire city as a whole, doesn't actually have connection to the internet yet. So we're going to set up that connection to the internet through an internet gateway. So you can think of the internet gateway as a little component that has one arm to the internet and then the other arm to the VPC. And it's just like connecting these two components inside. And how we're going to do that is finding the internet gateway over here, selecting create internet gateway, and in the name, we're going to type in network IG. Just like that, let's choose create internet gateway, and done. We've created the internet gateway. So what we've created here is an internet gateway that kind of just has like its arms out, but it's not really connecting to anything yet. Technically what we've just created is just the internet gateway itself. We've named it network IG, we have named it network internet gateway, but how does this internet gateway actually connect to your VPC? How does it actually have this little arrow, this little link to your VPC? How we're going to do that is by attaching it to the VPC. So it's actually super easy to do that in AWS. All you have to do is click on the actions bar and then click on attach to VPC. So now here, we're going to select network VPC, and voila, we can add our internet gateway, just like that. Okay, so attaching it, as you can imagine, is a very, very important step. This is something we mentioned in the previous project as well, but we're going to mention it again, especially with VPCs. Setting up the connections is just as important as setting up the resources themselves. It's kind of like saying in a complicated diagram like this, it is very interesting to be like, ooh, there's this component here, there's this component here, very interesting. Our eyes get drawn to the components, but what's equally as important is setting up those lines between the components, like the arrows between these components. Because if these resources aren't talking to each other, there's really no point in setting up such a complex architecture. You need these things to be connected, to be talking to each other for your VPC to work. And attaching your internet gateway to the VPC is one of the examples of setting up that link, which is very simple. It was very easy. It was 1 second, but extremely important. Okay, now that the internet gateway is set up and is attached to the VPC, what we're going to do next is we're going to create a route table. So route tables are truly I honestly think of them as GPSs. Some people think of them as traffic cops, but really you can think of route tables as the reason why resources know the way to get to somewhere else in your network. You can think of, honestly, imagine this. You have your city, you have your neighborhood, you have set up an internet gateway, you have set up your components, you've built buildings inside your city, but no one in your city has a sense of direction. Everyone is always just lost. No one knows how to get home. No one knows how to get out of the city. No one knows how to get to someone else's house. Everyone's just loses their sense of direction. And they need route tables to really navigate around your city. So if route tables didn't exist, traffic between your resources would get extremely lost. They wouldn't know how to get to the internet gateway and leave your VPC, for example. And that's why they're extremely, extremely important. And let's create the route table over here. As a heads up, if you're new here and this is your first time doing a networking project, creating a route table is actually the start of part 2 of this project series. So if you ever get lost, from now on, you can refer to the video for project 2 in this series, and the link to that is in the bio. Okay, so we're gonna create a route table now. And this route table, oh, actually we don't need to create the route table. All we have to do is rename a route table that's already been set up for us. Sorry about that, I almost missed that point. So what's happening here is if you were to refresh your page, you're gonna notice that there are already 2 route tables in your AWS account. So we have a route table that is no name, and another route table that has no name. So how can we figure out what's going on with these route tables? Absolutely drag up these 2 lines here. If you see these 2 lines at the bottom of your AWS page, just scroll it up like this. And absolutely, you're gonna need to select on the routes tab to really understand what's going on here. Okay, so this route table has a route to an internet gateway. It also has a route to a very big CIDR block, 172.31.0.0/16. But notice how this CIDR block is kind of new to us. We haven't really seen it throughout this project so far. It's definitely not the CIDR block we've set up for our VPC. So let's select the other route table. And let's check the routes here. Aha! 10.0.0.0/16. That is the CIDR block that we've set up for our VPC. So yes, this is the route table that is the default route table that was set up for your VPC the moment you created your VPC. AWS is just like, oh, you're creating a city? Okay, yeah, your people are gonna need a GPS. They're gonna be so directionless without one. So AWS has kindly created a default one on our behalf. So even if we don't create one manually ourselves, our resources still are able to travel within the VPC. And you can tell they can do that because the route that's in your default route table has a destination of 10.0.0.0/16, which means any traffic that is trying to get to somewhere else within your VPC has a way to do it. The way to do it is a route called local. And this is just something that AWS has set up, and it just means that it is able to safely route or direct traffic that is wanting to get to somewhere else in your VPC. We kind of call this like internal communication because it is actually traffic that's coming from within the VPC, also trying to get to another resource in your VPC, and that's why it's called a local route. Oh, Joe in the chat says, oh, hi, Nat. Hey, Joe, saying hi back. All right, so since we already have a default route table set up, all we have to do is rename it. So we're going to rename this to Network route table like this. And then we're going to click save. And then we are going to choose edit routes over here. And then we're going to add a new route. So you might be wondering, why are we adding a new route? And as a reminder, we've set up an internet gateway. And the internet gateway is supposed to take traffic outside of the VPC and into the internet. But as you might recall, the destination 10.0.0.0/16, it is local traffic. It is just getting to somewhere else within your city. It is not for getting outside of your city. So technically, there's no way for resources or traffic within your VPC to access the outside internet yet. And that's why we need to create a new route. We need to almost add to our GPS. Oh yeah, if any traffic within my VPC, within my city is trying to get out, is trying to leave my VPC, please show them the way. That's what we're doing by adding a new route to the route table. So how we're going to do that is in this new route, we're going to click on 0.0.0.0.0/0/0. I feel like I always toggle between 0 and O when I say this number, but bear with me. If I say O or 0, I'm really just saying the same number here. And then the target for that is going to be the internet gateway. So what we're saying here is, yeah, if any resource is wanting to leave the VPC, it's trying to go to somewhere that's not somewhere that's local, just send them on this pathway to the internet gateway. It's going to send them out, like it's going to take them out of the VPC. So that's perfect, and we're going to save changes. Voila! Our route table is all updated. Very, very good. I don't think our job here is done though. because now that we've set up a route table that properly knows how to route traffic internally within the VPC and also outside to the outside world, to the internet, there's still one step that's missing. The one step that's missing is associating your route table with the subnet. So again, remember how we said the components of a VPC are important, but the links between your components are just as important? This is coming through once more. So we've set up the route table, but technically, even if you've set up the route table, you need to make sure that you are linking that route table to the specific neighborhoods that you want access, that you want to have access to that GPS you've set up. So it's kind of like saying, like, you've created the GPS. This GPS is going to be genius. It's going to teach people how to travel within your city, but also leave the city. But you don't provide that GPS to people in this neighborhood or to people in another neighborhood. And now, even if that GPS exists, because people in your neighborhood don't have access to that GPS, they're still going to get lost anyway. So we're going to make sure that everyone in the public subnet that we've set up, that public neighborhood that we've set up, has access to this GPS. And how we do that is by creating subnet associations. So we're going to click on Edit Subnet Associations over here. And let's click on Public 1. And now we're really setting up an explicit association. So now it's explicit. We're making it very, very, very clear, and you can see the word explicit here as well. We're making it very clear that, hey, make sure that this subnet, this neighborhood, has this route table, has this GPS. Cool. So now your subnet is truly public because it is connected to the internet via an internet gateway. It has a route to the internet. That's awesome. Having this route is what makes a subnet public. So even if I called my subnet public, I had this route table, I had this internet gateway, if that route table wasn't associated with my public subnet, my subnet wouldn't have been public. So that step, like connecting those two components, was very important to make that happen. Oh, Joe said, I read somewhere that it's someone's birthday. Yeah, that's so sweet. Thank you so much. It is. We even celebrated with a bit of cake today at the office, and I'm still getting to enjoy some amazing pink cake, which is really matching the pink outfit today, actually, which is awesome. Thank you so much, Joe. That's so, so sweet. All right, now that we have the route table set up, we have the GPS set up, it's time to talk about security. So security is where we're going to have a bit of fun with network ACLs and security groups. We've already done these steps before, again, in project 2 of the series, so we're going to whiz by these steps a little bit, but we're going to create a security group, and then we're going to call that security group Network Public Security Group over here. Give that a handy description as well. Let's just call this a security group for the Network Public, Network VPC Public Subnet. Very logical. And the VPC the security group is going to be associated with shouldn't be your AWS account's default VPC. It should be your AWS account's Network VPC, the new one that you've just set up. So let's click on that. And under the Inbound Rules tab, let's click on Add Rule. We're going to add a new rule. And we're going to call that HTTP, like that. And then the source type should be anywhere IPv4. And at the bottom of the screen, we're going to create the security group just like that. Cool. Now that that's created, let's create the network ACL. So the network ACL, again, is another security component, for a VPC, but the network ACL works on a subnet level. So, actually, we don't even need to create a new one. I think we actually just need to rename an existing one again. So similar to how the route table has already been set up for us by default, you can say the same thing about the network ACL. There's actually been a default one that's set up when you created your VPC, and you can see it right over here. So if you click on that, and you can scroll here as well, scroll in this page to see that it's already associated with your public subnet by default. And then it's already associated with your network VPC by default. Super, super handy to have that already set up for us. And all we have to do is rename it. So let's click on the pencil icon and let's rename it to Network ACL. A bit of a tongue twister. If you're curious what really are security groups, what are network ACLs, how are they different, we talk about that in detail in Project 2 of the networking series. So I hope to see you there as well. Cool. And yeah, let's check out the inbound and outbound rules tab for this. And you're gonna see that already by default, this default network ACL that's already been set up by us, we didn't even need to create it, already allows in all traffic and allows out all kinds of traffic. Perfect, that is exactly what we want. Plaxidus, welcome back, Plaxidus. Plaxidus says, hey, and Dylan says, hey everyone, joining from Malaysia. Oh, that's cool, Dylan. Welcome, welcome. I hope you enjoyed this project. Wendy says, is it your birthday? It is. Thank you so much, Wendy. That's super, super kind. All right. So with that set up, you have your security group set up, you have the network ACL set up, and now we're going to move into project 3 of this networking series. The steps for those, they were to create a private subnet and private resources, and that's what we're going to set up here as well. So we've created the public resources in the bottom row over here. And now we're going to create some private resources at the top row. Okay, so for now, we're just going to start by creating the private subnet. And that is this little blue rectangle over here. Remember how subnets are like neighborhoods? So the public subnet is a subnet where everything inside is going to be publicly accessible to the internet. And then a private subnet, which is what we're creating in this blue area over here, is a subnet where all the resources inside are private. It's basically like neighborhoods in a city where every house inside is a residential area. It is not a library or a mall or a swimming pool or a park. It is just someone's house. No one from the public should be able to just like waltz in and say like, hey, what's up? It is a neighborhood of private resources, and they are so good to have because you would want sensitive, confidential information or applications to be kept in private subnets to really protect them from any attacks from the public internet. So still in the VPC console, we're still going to stay here, but we're going to go back to the subnets tab now. And in the subnets tab, we're going to create a new subnet. And then for the VPC ID, we're going to select the VPC drop down and select Network VPC. Oh, thank you so much to Joe and Wendy for saying happy birthday. And King of Zamunda, welcome back. It was so good to have you last week, and I'm so happy to see you again. You're saying, how are you, Natasha? Seems I am a little late. That is all good, King of Zamunda. I think what's more important is that you're here now. That is so sweet of you. Thanks for spending time here, and I hope you enjoyed this project. So we're going to select the Network VPC because we're creating a new subnet. We're creating a new neighborhood right now, but again, it's going to be in the same city. It's just that this VPC is going to be, this subnet is going to be private. And yes, when we create this new subnet, we're just going to call this very explicitly our private subnet. And then for the availability zone, we're just going to play around right now, and we're going to click the second on the list. This step, again, is not important. If you want to click on the first, you honestly can. We're just wanting to show you that you can actually deploy subnets, you can deploy resources in different availability zones within the same region. But for now, it's not going to impact your account too much or your project too much if you were to select the same availability zone, as a heads up. And then for the IPv4 VPC CIDR block, again, this is just another reminder. Hey, by the way, this is the block of addresses that are available to you in your entire city. And for us, we're just going to make sure that our subnet's CIDR block is 10.0.1.0/24. Again, another block of 256 IP addresses, but this time notice how our block of IP addresses, that starting definition has 10.0.1.0, not 10.0.0.0. Because if it was the same 10.0.0.0 like this, if you were to try to create your subnet, you're going to notice that you can't even create the subnet itself because it's going to say, hey, in your city, you already have an entire neighborhood with this exact same set of addresses. You can't have overlapping addresses within a VPC. It's kind of like how you can't really say one house belongs to two suburbs at a time. Like, no. I'm pretty sure this a house in a city could only belong to one suburb at a time. So we're going to make sure that all of the addresses within a subnet is completely unique. And that's why our CIDR block definition also needs to be completely unique as well. And 10.0.1.0/24, make sure that there is no overlap in the addresses between our public and our private subnets. So once that's set up, let's try clicking on create subnet one more time. And look at that, we could create a private subnet just like that. So that was pretty fast. We've just created a whole private neighborhood. And to tidy up your subnet's naming conventions, let's just make sure that the public subnet is no longer just called this generic public one. We can have a naming convention now, very slick. And we're going to call it the Network VPC public subnet instead. Just like that. Gonna click save. Done. Very nice. And what we're going to do now is we're going to create a dedicated route table for your public subnet. So again, for your private subnet. Sorry, there's a typo over here. It should say dedicated route table for your private subnet. And I am going to quickly note this down that we should be updating the wording for this. But yes, just like how your public subnet needed a GPS, your private subnet definitely needs that too. Because what's going to happen is you're going to notice that your public subnet's GPS or your public subnet's route table, if you look here, the routes has a route to the public internet. Technically, you can click on subnet associations here, and you can just click edit subnet associations. Oh yeah, let's give this GPS to my private subnet too. Security-wise, is that a good idea? Have a little think. Security-wise, is it a good idea to give your private subnet a GPS that has a route to the internet? Unfortunately not. If you were to give your private subnet a whole GPS, give the resources, give the internet a way to access your private subnet's resources, or give a way for your private subnet's resources to leave the VPC and enter into the internet, it's probably not a very, very good thing for in knowing that a private subnet's resources should be kept completely separate and just inaccessible to the internet. So we're going to create a new GPS that only has routes to another resource within the VPC. So it's kind of like a second version of that GPS, but that GPS completely does not know how to take you to the internet. So people or traffic resources in your private subnet won't be able to leave. And also traffic coming from the internet, from the outside world, won't be able to enter, your private subnet because that route table doesn't exist. All right, so we're gonna just head to the route table page over here, and then we're gonna create a new route table just like this. Let's click on create route table, and we're gonna name that route table Network private route table, just like that. Paste that over here, and again, VPC, make sure you're not selecting the default one. Make sure you're selecting Network VPC. Make sure this GPS is belonging to your own city that you've set up, not the default AWS account VPC. So once you've selected that, we can just select on Create Route Table. Voila! Here we are. We have created the private route table, and what we're going to do is we're going to double check the routes, because there really should only be one route in this route table, and that's just a route to a local route to another resource within your VPC. And of course, let's create that subnet association. Again, we've created the resource, we've created the component, and we're just going to make sure that we have that connection, that link set up too. So once I've clicked on Edit Subnet Associations, I'm going to make sure that I select the checkbox next to Network Private Subnet. Please make sure you select that checkbox, and then we're going to click on Save Associations. done. So just like that, you've created that link between your GPS and between your private route table, your private GPS with the private subnet. Now, resources in your private subnet are no longer going to have a GPS that could take them to the internet, and are only going to have a new GPS that you've created that's only going to let them travel within the city, within the VPC. Great job, by the way. That is hard work. Again, in this list, do you see how the naming conventions aren't quite tidy anymore? It is honestly great AWS organization or AWS like best practice to keep the naming system pretty consistent. So let's do that. So where it says, next to private route table, that's the name we've given to our new route table. We're going to want to make sure that the older route table, or the one we've created earlier in this project, has a very similar kind of naming style. But instead of private, of course, this one is actually public because it has that route to the internet gateway. Okay, cool. Awesome. It's good to have that public route table renamed now. And that leads us to pretty much the final part of our setup for this project today. And let's create a dedicated network ACL just for the public subnet. So if we were to have a look at the network ACLs page, let's click here. Let's refresh just to make sure that we have the latest version of our network ACLs page. And let's click on, again, the ACL that's the default ACL for our VPC. You're going to notice here it says it's associated with 2 subnets. Before, it was by default associated with public 1, our public subnet. Now it's associated with 2. What? Look, we created the private subnet, we've created our private neighborhood, but by default, it is already being associated with our network ACL, the VPC's default network ACL. Is that a problem? Is it a problem that the network ACL, or the security watchman that's supposed to be protecting our entire neighborhood, our entire subnet, or you can also say the network ACL protects protects resources at the subnet level? Is it okay that the network ACL is also associated with the private subnet when our network ACL currently is letting in all traffic and letting out all traffic? Is that a good idea? Let's ponder on that for a second while I check the chat as well. King of Zamunda says, sorry, Natasha, when you say GPS, you mean group policy setting, or I'm kind of lost in the abbreviations? Oh, that's okay. Thank you so much for the suggestion. So when I say GPS, the group policy setting, not exactly. So the GPS I am referring to is the route table. So over here, looking at the diagram over here, the GPS that I was referring to, or the GPS analogy that we've been following for this project series, are the route tables over here. So as a recap, the route tables are how are kind of like the component in your VPC that directs traffic within the VPC or within the entire network. So without a route table, or without the route tables in your VPC, resources in your subnet or resources from outside your VPC will struggle to find their way around their network. It's kind of like they've just completely lost their sense of direction. At the end of the day, the VPC is all about setting up connections between your resources. So you absolutely need route tables to kind of say, oh, you want to get to another resource, you want to direct traffic to another resource in the VPC, this is how you can get there. Or, oh, you're from like the public internet, you're wanting to get access to an EC2 instance in the public subnet. This is how you get there. So yes, it is absolutely an analogy. And yeah, thank you so much for updating me. That's all clear now. Thank you so much, King of Zamunda. All right, so now that we're looking at the network ACLs, I'm just gonna quickly scroll there. Perfect, we're here now. So now that we're at the network ACLs, yeah, our network ACL that is associated with the private subnet has an outbound rule that allows all traffic, and it has an inbound rule that allows all traffic What? It's not actually a good idea security-wise to be letting in all kinds of traffic. Knowing that our private subnet is supposed to be keeping our resources private, letting in all kinds of traffic is probably not going to be keeping our resources private. It's probably not going to help our private subnet do its job. So we're going to create a new network ACL to make sure that the subnet, our private subnet, is really being protected at the subnet level, because the network ACL should have extremely strict inbound and outbound rules that only restrict traffic to traffic that we trust already. So when we create this new network ACL, we're going to make it very clear that this network ACL, or abbreviated here as NACL, is a private one. So that's why the name is called Network Private NACL. And in the VPC, the city that it's associated with is called Network VPC. Okay, and we're going to create that network ACL, and let's see what's happening here. Whoa, interesting, eh? If you were to look at the inbound rules, oops, that's not the ACL that we've just created. Let's make sure we're selecting the private NACL. My bad. Interesting stuff that if you click on the inbound rules now, you're going to notice that all kinds of traffic is now denied. And all kinds of outbound traffic are all denied as well. So in this private NACL, we're really just trying to deny all traffic by default and only let in traffic as we see fit. So we're not even going to set up any rule that's going to allow traffic yet. We're only going to set up rules that allow traffic when we know exactly what kind of traffic we want to allow. So that is a really, really great security practice for your private subnet. And again, now that our network ACL is created, we need to make sure that the link between the private ACL, we're going to make sure that the private network ACL that we've created here actually has that connection. Do you see that arrow to the private subnet? We're now going to set up this arrow over here by creating the subnet association. So let's click on subnet association. Let's click on edit subnet associations and select your private subnet. So we're going to select that and save your changes. There we go. Awesome. So once that's done, the last step before we can move on to new steps for this project is just to rename your public network ACL so it's following the same naming conventions. Perfect. Save that. Done. Okay, so once that's done, we can now dive into step 2 and onwards and upwards. Oh, very, very good point, by the way. If you're wondering, why didn't we need to set up a private security group? It's because later in this project, in step 3, you're going to learn a different way to set up security groups. And we won't be using the VPC console for it. Cool. Okay, now we're going to launch a public EC2 instance. And in this step, you're going to create a new EC2 instance. You're going to find a way for you to access your EC2 instance. There are a lot of cool learnings in that one. And then you're going to put your EC2 instance in the VPC that you've set up. So we're going to get your VPC to work in this step. So let's get started with that. We're going to go to the search bar at the top, and we're going to click on EC2 over here. And once we've search for EC2, we're going to select EC2 in the services list. Perfect. And then we're going to select instances in the left-hand navigation bar, like this. All right, once we've selected that, we're going to launch an instance, and we're going to call it the Network Public Server. Ooh, interesting. If you're new to EC2 instances, by the way, you will absolutely get an intro to what are EC2 instances if you check out our security and IAM project. The link to that is in the description as well. For now, just know that an EC2 instance is a virtual machine. And a virtual machine is basically like the computer that you're seeing in front of you that's running this video that you're watching right now. But imagine if that computer is in the cloud and you're controlling that computer and you're installing things, you're operating it remotely from yours. So what we're going to set up that public server over here. And for the Amazon machine image, make sure that whatever you select, just make sure it's free tier eligible. Okay, we're going to select Amazon Linux 2023 AMI because it's the latest one that is free tier eligible. And then we're going to select T2.micro as our instance type. Again, whatever you select, just make sure it's free tier eligible so you don't get charged. Because if you choose one of the other options, you're going to get charged by the hour. All right, you might be new to the concept of AMIs over here and instance types over here. And truly, in short, think of AMIs and instance types as a way to just configure and set up this virtual computer that you're creating. If you'd like to dive into the definitions of both, you can think of AMI as selecting a pre-built computer. Kind of like how when you walk into a computer store and you buy a new computer, you didn't have to set up or build that computer from scratch yourself. There's already a MacBook laptop or a Windows laptop that's already been built for you. And that's kind of like what we're doing by choosing an AMI. We're kind of like just selecting a pre-built computer and just walking out of the store with that. Super happy. But then the instance type are small little ways you can still configure your computer after buying it. It's kind of like when you are buying a Windows or a MacBook, there's still like a range of MacBooks you can choose from. It's not just like, oh, you want a MacBook? Here's the one option you have. There's always like, oh, you want a MacBook? We have MacBook Airs, MacBook Pros. We have within MacBook Pros, you can choose different kinds of chips. You can choose different kinds of memory setups or storage capabilities, and that is kind of like the same with an instance type. So instance types give you like pre-built software and operating system. If AMIs give you like the pre-built software and operating systems, instance type cover kind of like the hardware components. So things like the memory size, the storage space. It's just like the different types of MacBooks or the different configurations that you can be getting for the same kind of type of laptop. Cool. So for the key pair login or panel, this is where we're going to learn something new. So we haven't really talked about key pairs so far in our series of AWS projects. So in today's project, we're going to get into that new territory by creating a key pair. And this step truly is going to focus on this concept of a key pair. So if it's so no worries at all if you feel like, oh, like I hope I'm not taking too long to learn the concept of a key pair, because I would say even if it takes you like most of the step or most of the time that you're spending on the step just on understanding key pairs, that's an absolutely worthwhile investment, just as a heads up. So what are key pairs? Why does this option exist in this EC2 setup? Like, I'm just trying to create a virtual machine. Why are they telling me about key pairs? What even are they? So key pairs, in short, help engineers, help developers directly access their virtual machines like EC2 instances. That's why they exist in an EC2 instances like setup flow, because key pairs help you connect to the computer that you're about to set up. The concept of directly connecting is something that we're not very familiar with, because it could be like, well, I've been controlling my EC2 instance just by using the AWS Management Console. Isn't that like directly accessing your EC2 instance? Not exactly. There's a difference here. So directly accessing a virtual machine means like logging into the machine, managing the operating system, managing the software like you were just using it in front of you. It's just that you're doing this over the internet. The management console, or this screen that we have usually to navigate our resources, to create our resources, isn't the only way to create resources. This console here gives you a very user-friendly interface. It is great for learning, but it doesn't typically provide direct access to the operating system of an EC2 instance you're about to launch. So for operations or for projects that require direct access, you will need things like key pairs. And examples of operations or things that might require direct access is like installing software directly into your EC2 instance, editing some of its configurations, running things like scripts within that EC2 instance. You would need something like a key pair to connect to it directly. So a key pair is kind of like a very, very advanced way of having like security or authentication for your EC2 instance. Kind of like how when you are like buying your own laptop, you can set up a password for that laptop, or you can even set up like facial recognition and touch ID for your laptop. You can think of key pair as that very, very important authentication step before you can actually access the computer. And why we're needing it in this project series is because we're going to need to directly access this EC2 instance you're launching inside your public server. We're going to need to directly access this public server in a future project. So this and creating a new key pair is absolutely key to kind of like preparing us for that next project in this series. So just for this step, sorry, I almost choked again. But anyway, just for this step, let's click on create new pair over here. And then for the key pair name, we're gonna use Nextwork key pair like this. Oh, my key pair already exists, that's my bad. So I'm just gonna select the key pair later. But let's just say you're gonna call your key pair Nextwork key pair. And then for the key pair type, use RSA, and then the key pair file format is .pem. So what's happening here is you have a key pair type, but then a private key file format. What do these things mean? Now, how key pairs work is, as I mentioned before, it's kind of like that authentication method, or it's kind of like typing in your password, but a very advanced way of doing it. How key pairs work, the reason why it's called a key pair is because it's actually a set of two keys. One key is with you, and one key is with the EC2 instance that you're about to launch. And what's going to happen is whenever you try to directly connect or directly access your virtual machine is going to say, I have a key, a private key. I'm going to need to see your private key, and we're going to see if these two private keys can link up, if they match. If they match, congrats, you have direct access to this EC2 instance. If they don't match, you don't have access to this EC2 instance. So that's why key pairs are extremely important to set up. And a key pair type, it basically determines the algorithm that's just used to generate the key pairs, kind of like passwords. And RSA is one of the most common algorithms used. It is something that we would just use by default. Whereas the private key file format is basically just like the file type for your copy of the key that you're going to download into your computer, into your local computer. So it's kind of like how a Word doc or a document, text document, can be saved in different kinds of file formats. Like, oh, do you want a Word doc? Do you want it in a text file? Do you want it in a PDF? Private key file formats are like the same thing. It's just like, hey, we're going to give you a private key. What kind of file format do you want? .pem and .ppk, we're not very familiar with these. So typically you would just go with .pem. And that's because it is the more common private key file format. And also, fun fact, it used to just start off as a way to secure emails, but it's just become this go-to format for managing cryptographic keys as well, just because it is just so widely supported by all different kinds of servers. EC2 instances are one of them. Sometimes if you have a very complicated private key file format, a server that you want to match it with might not actually be able to read it. And it's kind of like, say, if you were to try to open a Word doc in a computer that doesn't have Word running, it'll be like, sorry, like, I know you have a document here, and I can read documents, but I can't read Word documents. And in contrast, most computers can open PDFs. Most computers can support PDFs or simple text files. So it's kind of like the reason why we choose .pem, because it is just a very, very accessible kind of private key file format that a lot of different kinds of servers accept. So we're going to click Create Key Pair. And you're going to notice that when you click on Create Key Pair, you couldn't see it just now because I have my window kind of maxed out. But when you click on Create Key Pair, an item's going to start downloading here. And you can see in my recent download history, there's been a key pair downloaded into my computer. And this, sorry, not a whole key pair, sorry, but a private key in .pem, which is the file format we chose, has been downloaded into my computer. So what's happened here is it said, you've created a key pair, congrats. Here is your private key that's going to need to match up to that EC2 instance's private key. And as you can imagine, private keys are extremely important to store very, very safely. And it is quite important to store it safely because it cannot be downloaded again from AWS once it's been created. Once that key's been created, AWS is going to make it so protected and secure by making sure that no one else can download that private key. So isn't that slightly stressful? I have to admit, when I first learned about the way key pairs work, I'm like, man, like I feel like it is going to be very easy for me to lose my half of this key pair. That's going to make trying to directly access my EC2 instance a little bit stressful. But luckily, for this project, we're actually going to be using a shortcut or a simpler technique to directly access your EC2 instance. And this shortcut technique actually skips the need for a key pair that you set up manually. We are just creating a key pair in this step purely for learning purposes, but actually later in this project series, in the next project, when we are going to directly connect to our EC2 instance, we're going to be using a method that doesn't need this key pair actually. It is going to be using a shortcut way that we're going to learn about in that project. So in this case, with that private key file that you've downloaded, I'm going to literally demonstrate it so you can see. You can literally delete that right now and it's not going to matter because the way that we're going to access our EC2 instance is going to be a bit simpler than needing the key pair. Cool, so I hope that was clear. Truly, the reason why we created the key pair in the first place is for learning purposes, but we won't be really needing it later in this project series. Awesome. So with that being said, that is key pairs learned. Ticked. Congratulations. You've learned about key pairs. And let's switch gears back into the VPC side of things. So you're going to notice that network settings has a few things already set up by default for us. There's a network setup for us, a subnet setup for us, a few like security groups even set up for us. We've created our own VPC, our own way of connecting our resources, and we're going to put it to work. So that's why we're going to click on Edit in the right-hand corner of the Network Settings panel. And then in the VPC required field, we're going to say, hello, don't launch this in the default VPC. Actually, I've created my own VPC. We're going to be using it. It's called Nextdoor VPC. So like that. And then for the subnet, AWS is saying, oh, okay, you have your own city. You want to launch this EC2 instance in. Congrats, that sounds great. Which subnet, which neighborhood in your city is your EC2 instance going to be living in? It's kind of like saying, hey, I want to build a new building. I'm going to build a new EC2 instance. EC2 instance is the building. Which neighborhood should your building sit in? And for this step, we're creating a public server. So of course, it should be in a public subnet. And then for the security group, doesn't your public subnet already have an associated security group? Yes, it does. So we're just going to select an existing security group and select the security group that you've set up already. It's called public security group. Nice. So once that's all done, you can launch your instance. Super exciting. Let's launch it. Off we go. Nice. Just like that, we've created an EC2 instance. Isn't that awesome? I think that's pretty cool. So we're going to head back to the instances page. We're going to select on Nextdoor public server like this, and we're going to drag this up like this. And then look at how there's a networking tab inside this instance details panel. Click on networking. Aha! You're going to see that there's a bunch of networking setup or configuration all laid out in this page for us. So convenient. Now I get to see exactly what subnet this EC2 instance belongs in. It belongs in my public subnet. It belongs in this availability zone. You know, it's belonging to my Nextdoor VPC. We have a public IPv4 address, and that's because we had earlier in this project, we had clicked that little checkbox that says enable automatic like assigning of that public IPv4 address for every single resource in the public server. And to see now that we have a public IPv4 address for this public server, very satisfying to see it actually like in action now. So with that, we have finished the first, the step 2 of this project, and we're gonna take a screenshot. So let's take a screenshot now, and let's put that into our step-by-step guide. So no more needing to flick over to Canva or anything like that. It's gonna be very, very easy for us to set up a documentation for us just by answering these prompts. So just like that, I'm gonna just screenshot the networking tab for my EC2 instance, and I'm gonna plop that into the page. Perfect. Wow, just like that, I've dragged it over. It's already uploaded. Amazing. Now let's answer a few questions. So the first question is, what is a key pair? And I'm gonna say key pairs are tools that help developers, engineers authenticate themselves when trying to get direct access to a virtual machine, e.g., an EC2 instance. And I'm going to quickly have a quick peek at the next question. Oh, okay, what does it mean to directly access the EC2 instance? Ooh, a good question. But for now, since I'm not being asked, I shall just automatically also talk about something else. I think I'm going to talk about, I would be keen to talk about how key pairs work. Key pairs work by having 2 private keys, a private key for the VM, the virtual machine, and a matching private key for, oh, I've maxed out the characters. Oh my goodness. Key pairs are tools that help, well, I'm going to be more concise, that help engineers authenticate themselves when getting direct access to a virtual machine, e.g. an EC2 instance. Key pairs work by having 2 private keys, a private key for the VM and a matching private key for the resource or the user that's trying to get access. Cool, once that's done, I'm going to click on the arrow button and jump to the next question. Oh my goodness, so simple. What does it mean to directly access your EC2 instance? Directly accessing a virtual machine means, ooh, do we know this? Let's talk about this. Directly accessing a virtual machine means, let's say like logging into the EC2 instance instead of just managing it at a higher level with the AWS Management Console. This includes operations like installing software and changing my EC2 instance's configurations. Phew! 1 character left. I feel like every time I'm typing out an answer, it's a bit of a battle between me and the character count. We're gonna see who makes it out of this fight every time. Okay. Very good question. Tam says, what if I lost my key pair, so I need to create another EC2 for working? Oh my gosh, no, not at all. If you lose your key pair, there absolutely is another way to set one up. You won't need to create a whole other EC2 instance just because of losing a key pair. Yeah, very, very good question though. Imagine if you had to just create a whole new EC2 instance every time you lost the key pair. All right. What is a private key's file format? Which format was your private key? Ooh. So remember what we talked about with the .pen file? We're going to mention that here now. So a private key's file format means that the file type that my key is stored in. My private keys file format was .pem, which is a widely accepted file format that most servers will be able to read or use, is what I'll say. Awesome. So with that, next prompt. How did you edit your EC2 instance's networking settings? Ooh, I had to change my EC2 instance's networking settings by, yes, I had to change my EC2 instance's networking settings by changing the VPC subnet and the subnet my EC2 instance was going to be launched in. I updated both to my, what is it called? To my network VPC. And my public subnet, respectively. I also used my existing public security group. One character left. Whoa! Whoa! It truly is a battle between me and the character count. That's what happens when you're a bit of a chatty one, I'd say, I guess. All right, I'm quite happy with my responses here, so I'm just gonna click done. Woohoo! That's all done. Next, step 3, let's launch a private EC2 instance. So we've launched the public instance, the public server, and now we're gonna launch the private counterpart. So now that the public one's done, we're gonna move on to what's highlighted in the blue frame now. We're gonna launch this thing over here. As you might recall, we haven't even set up the private security group. So we're gonna be learning that new flow on how we can create the private security group as well. So yeah, in this step, let's launch another EC2 instance. Practice makes perfect. It is always a good idea to be repeating steps to really know that you're understanding things, like learnings are like in here. And then we're gonna protect this EC2 instance. We're gonna create that security group. And then we're gonna set up a way for our EC2 instances to speak to each other. That's huge. So again, let's launch our EC2 instance. Select on launch instances. And then under name and tags, let us use the name network private server to represent that this EC2 instance is going to be in my private subnet. And again, Amazon, machine, image, AMI, is going to be okay to just stick with the same one. Instance type, again, it's okay to stick with the same one. Key pair, let's use a key pair that we've created from last time and that we were using from last time. That's the network key pair. And then we're gonna use a security group. But again, with our VPC and now with the private subnet, we talked about creating a security group in a different way. And how we're gonna do that is by, instead of selecting an existing security group, which is what we did for the last EC2 instance, we're gonna be creating that security group. Woohoo! It's gonna be cool. Now that we're going to create a new security group, let us give it a name. You can even write a description. You can even set up the security group rules all within the same flow. Isn't it so convenient? It really is. Like, I think actually it is a really good idea to be setting up a security group for every instance as they show up, like this. But if you'd ever like to preset that security group and create a template, because let's say you are launching 50 EC2 instances, and honestly, the instance level inbound and outbound rules are the same across all 50, it's probably a good idea to just set up one security group and then continue to select the existing one each time. It's always good to be doing things at a mass level or having ways to change things at a mass level. If you can foresee that all of these resources will always have the exact same settings between them. But otherwise, you can create them instance by instance, the case by case basis almost. And for our new security group, let us call it the private security group, like this. And then we can even create a description. So there's already a default description that just says like, oh, this was created with the launch wizard. But let us have a more informative description by calling it a security group for the Nextwork private subnet. All right. Notice how when I scroll down here, I didn't even need to set up inbound security group rules. It's already been set up for me. The type is set to SSH. And what does SSH mean? This is a really exciting part, I would say, of learning about networks and learning about resources inside your VPC. And also just in general, as a cloud engineer or learning about cloud computing, you're gonna really, really notice SSH in the future. So it's a good idea to be learning about SSH now. So what is SSH? Remember how we created that new key pair to get direct access to an EC2 instance? SSH, which stands for Secure Shell, is the protocol we use for the secure access to the remote machine. When you connect to an instance, SSH is the protocol that's verifying you have the correct private key. So you know how we said a key pair has that private key that you keep, and it is also the private key that the EC2 instance has? SSH is the protocol that matches your key with the EC2 instance key and say, oh yeah, they match, pass. Like that's the protocol that's making this connection or making this matching happen. That's why SSH is extremely, extremely important. And you're going to notice, though, that the reason why it's in a security group rule is because in terms of network communication, SSH is also a type of network traffic. So it's not just a way to match keys together. SSH is extremely common because it's also a type of traffic. So once SSH has established that secure connection between you and the EC2 instance, once it's done the matching and said, okay, you guys do have the same, you guys do have matching key pairs, all the data transmitted between yourself or the resource as well as the EC2 instance that you've connected with is going to be encrypted. It's going to be encrypted because of SSH. So this encryption really makes SSH an ideal method for securely exchanging confidential data like login credentials, and it's also why it's just such a widely used kind of traffic type as well. Yeah, this point, like how common is it for developers to use SSH, again really hones in that point. More and more organizations are trying to reduce the use of SSH, and they might prefer infrastructure as code and automated deployments to reduce the need for direct access to a computer. Because again, remember how SSH is really common because it helps us with directly accessing an EC2 instance. But right now, a trend that's going on right now is automation, using infrastructure as code, using scripts, so that you don't need that direct access to the EC2 instance personally. We're going to minimize human error. But at the same time, SSH access is still just so essential for many administrative, testing, and troubleshooting scenarios. For example, developers today, they use SSH to troubleshoot live issues, to do manual updates, configure system settings. These are things that you probably can't really do with the AWS Management Console. You can manage your EC2 instance, their organization with the Management Console, but not exactly actually directly going in and try to troubleshoot live issues like this. So truly, directly accessing a virtual machine is a different level of it's a different level of interacting with your EC2 instance that's a bit beyond what we can do just from the AWS Management Console alone. And yeah, this security group rule has already been set up for us, but there's a little banner that's kind of warning us about this default security group rule. It's telling us that rules with the source of 0.0.0.0/0 allow all IP addresses to access your instance. And it's basically warning us and saying, by the way, you should probably set security group rules that only allow access from specific IP addresses or known IP addresses already. Using source type anywhere, a bit of a risky idea, is basically what it's saying. To be honest, here, we are we were totally okay with having our public subnet have a security group that allows all traffic. But are we going to be okay to do that for our private subnet, our private server? Probably not. So that's why we're going to change that source type from anywhere to custom. We're saying you're making a good point here. We don't really want all kinds of traffic to just from anywhere, traffic from anywhere to come and get access to our server, right? We only want to make sure that trusted traffic is being let in. In the scope, in the realm of private subnets, private servers, what is considered trusted is probably just another resource that you set up yourself and know how it's going to be trying to access your private server. With that being said, that means our source over here, it's not going to be all IP addresses anymore. We're actually going to scroll down and do something very, very cool. We're going to be selecting the security group for our public subnet. So select that. By creating this, by selecting our public security group instead of anywhere as our source, we're really saying that only resources from our public subnet, from our public neighborhood, can communicate with this instance, with this private server that's in the private subnet. Such a great source option to have, in my opinion. You're really just saying now only resources that's internal to your VPC can SSH, use secure shell to securely connect to your private server. So good. What a great move for just making sure your security groups are very specific, which is exactly really what we want for our private server. Awesome. So with that done, let's take a screenshot of your private EC2 instances security group settings. So that's kind of like just taking the screenshot over here like this. And let's put that over there into your documentation. So I think this looks okay as a scope for our screenshot. And let's take that screenshot now. So I'm gonna take a big screenshot that goes from the name all the way to the security group rules, and I'm gonna drag that into the page. Oof, nice. And let us answer a few questions. What does SSH mean? First question. Start your response with SSH traffic means, yeah, we're gonna say SSH traffic means secure. Oh, we have questions. 1 second. Can we also go ahead to use the CIDR for the VPC? Great question, King of Zamunda. I'm assuming you're asking, can we also use the VPC CIDR as our source? Yes, yeah, you definitely can. We can honestly give that a try right now just to show you what that could look like. So your VPC CIDR block is 10.0.0.0. Do you see how there's already the option here, /16? So you can definitely just choose that. That can be a source. And my question to you, King of Zamunda, would say, what is the difference between using 10.0.0.0/16 compared to the Network Public Security Group? What's the difference of choosing the Network Public Security Group instead? Yeah, a very, very good question to be thinking about. Oh, wow. Tam says, can I use the VPC CIDR for inbound to private security group for private EC2? Lol, exactly what I thought. Yeah, so Tam and King of Zamunda are asking the same question here. I love that. So the reason why we've used our security group, the Network Public Security Group, is because that is an even more specific group. That's even like small. That's an even smaller group compared to the entire VPC. Because if you're using the VPC CIDR, In the future, if you're ever creating another subnet, another neighborhood in your city, that city is automatically gonna also get access to your private subnet. Right now, you could be saying, well, whatever, like any neighborhood in my city could get access. I don't mind that. I mean, if that's the plan for your entire city and its future, that's cool. But imagine if that neighborhood isn't actually supposed to get access to your private subnet for security reasons. Again, we've talked about this in the last project, this principle of least privilege, but we can talk about this now as well. The principle of least privilege is a very important security principle that's basically saying don't give resources the access that it doesn't need. Only give users or resources the access that it absolutely needs, or rather their basic permissions in order to function correctly. In this scenario, only allowing the source to be the network public security group is a great practice of that principle, because it's really saying well, only resources in the security group needs access to my private server or to my private subnet, and we're gonna see those two our private subnet, our private server and the public server communicating. That's why they will absolutely need access to each other. But if I were to just grant it at the whole VPC level, in the future, if I were to add new resources to the VPC, they will automatically also get access to this private server. And that's not really the principle of least privilege in action. So I hope that helps to clarify the reason why we would select the network public security group instead of selecting something that's at the entire VPC's level, at the entire VPC level. But if you have any other questions about that, King of Zamunda or Tam, ask away. That was a very good question. Okay, so what we were going to do is to talk about these questions over here. So what does SSH mean? SSH traffic means, well, really, I'm going to be a bit cheeky and just say SSH means secure shell. And it is both a protocol and a traffic type. Oh, thank you, King of Zamunda and Tam. Yes, thanks for letting me know that it is clear now. Nice and easy explanation. Thanks. That's so cool. Very, very glad to hear. So SSH is both a protocol and a traffic type. So what it really does is it is the protocol that matches key pairs. And once a connection is set up, it is a traffic type that encrypts. I feel like if you say encrypts a lot, it starts to sound a little funny. So you can try saying encrypts to yourself a little bit, and then you're gonna be like, encrypts? Sounds a little funky. And SSH is a traffic type that encrypts communication data being transferred. Cool. Oh, I would actually just also mention it is the protocol that matches key pairs and enables direct VM. I'm holding my breath because my character count is getting dangerously low. Whew, 2 characters left. Not bad. So SSH means secure shell, and it is both a protocol and a traffic type. It is the protocol that matches key pairs and enables direct VM access, virtual machine access, or direct access to your EC2 instance. And once the connection is set up, it is a traffic type that encrypts or secures communication and the data that's being transferred. Poof, that was a good win. I'm very happy with that explanation there. And the next question says, why is your private server using a different security group from your public server? Start your response with, my private server has its own security group because, ooh, interesting. Why is that? My private server has its own dedicated security group because the network public security group The Network Public Security Group allows in all HTTP traffic, which would leave our private server much more vulnerable to security attacks or risks. Awesome. Once that's done, let us talk about what is your new security group source. I love this one so much. My private server's security group source is, which means, all right, so my private server security group source, that is a lot of S's. My private server's security group's source is my private, my Network Public Security Group. Which means only traffic or only SSH traffic coming from resources in that security group well, instead of resources in that security group, it's resources associated with that security group would be allowed. Nice. Just such a great way to secure your private server. Really love how security groups allows in or allows out traffic at the instance level. So really all the servers in a private subnet can still have slightly different rules to each other depending on what kind of server that they're connected with. It's kind of like saying, look, even if you have a database in your private server, maybe that database doesn't need to be connected to every single server in your public subnet. Maybe it only needs to be connected to one of the servers. And if it's that specific, you can set up your security group to literally say, only that specific server can have access to this database. That's how specific your security group can get, and absolutely would follow the principle of least privilege if you're doing that as well. So yeah, that's really cool. We're gonna click done, and then we're gonna move on. Whew, last step, everyone. We've made it to the last step. That was a whole journey. And we also have Michael Winton. Wow, Michael says, hello from Wellington. Happy birthday, Nat. Woohoo, thank you so much. I'm enjoying the last bit of the birthday cake right now. It has been delicious. It tastes really good with tea, by the way. Thank you so much to the special person that brought in this cake as well. It's made this birthday a fantastic day. All right, we're gonna move on to step 4, and that is about launching your VPC setup in minutes. Oh yeah, with that, let's make sure we're launching the instance itself before we launch into step 4. Okay, EC2 instance is launched. It's looking good. You know, you can even see the networking details for all of this. Chef's kiss. And with that being said, we now have the instances set up in your VPC as well. So that's awesome. It's cool to see that your VPC is able to host resources inside your city, can host, buildings now, and those buildings have completely separate environments. One is like a public mall or a public pool that anyone from the internet can access. And the other is kind of like a private residential building that's inside like a gated community or someone's house, and it's a lot more confidential. So very cool to have that set up. And in the next project, you're really going to be able to see some interesting things that you can configure. To really see your security group settings, your network ACL settings at work. Cool. So with step 4, we're actually going to learn how to launch this entire VPC architecture in minutes. Every time we've wanted to launch this VPC and all of its components, let's switch back into the VPC console so we can talk about this with a visual guide. Every single time we've wanted to launch our VPC, we've had to go into every single page to do it manually. We went into your VPCs, we went into subnets, we went into route tables, internet gateways, we went into the network ACLs, to the security groups. We've done quite a bit going into every single one of these pages individually. So what if we can have a way to set up a VPC that helps us skip all of these steps? So we're going to level up our VPC creation skills, and we're going to try a new way to create your entire VPC setup. It's a time saver. And yes, thank you so much, Michael Winton, for saying, glad you liked the cake. Have a lovely evening. Thank you, Michael. And thank you, Joe, for the cake emoji. Thank you so much. So yes, head back to your VPC console now. And from the left-hand navigation bar, we're going to select your VPCs. And then we're going to create a new VPC. So let's click on Create VPC on that top right-hand corner. Okay, clicked that. And we previously stuck to creating a VPC only, but now it is time to click on VPC and more. Yes, we're finally going to be using this visual guide that we've kind of almost been like coming across every single project but haven't touched yet, but we're finally using it now. It feels good. A whole visual diagram pops up that shows us other VPC resources. Look at that. This is just a preview mode for all of the resources you're going to get to create automatically in this one single flow. Like, look at that. You can even hover over things to look at their connections. It is so satisfying. It is so convenient, and it's so visual. We love visual aids. Honestly, visual aids help so much. And yes, this map is called a VPC resource map. And with a VPC resource map, you can quickly understand the architectural layout of a VPC. For example, the number of subnets, you can immediately see by default there's 4. Which subnets are associated with a route table. You can hover over a route table to immediately see which subnet you're about to create in this flow is going to be associated with the route table. By the way, all of these resources haven't been created yet. It's kind of like just a preview mode of resources that it's about to create. So very, very cool. And then you can even see which resources which route tables are connected to that internet gateway. You can hover over these components to see the relationships so quickly. So with this handy resource map, you get to see that selecting that VPC and more option over here lets you create so many resources at the same time and really saves you from jumping between pages in your VPC console. So we've already answered a few of these questions, but you can absolutely challenge yourself. How many subnets are being created? Ask yourself that. Out of that number of subnets, how many of those are going to be public? How many of those are going to be private? Can you tell just from this map? How many route tables are being created in your VPC? Why is it the number that it is? Have a little think about that. Is there an internet gateway being created? Can this single resource map answer all these questions? Give yourself a second and have a look at these questions and have a little think how you would respond to these. Okay, so I hope you've had a good reflection time with these questions, and let's go through the answers now. So how many subnets are being created? So convenient that you can literally see a subnet section that says 4 subnets are being created. And out of those subnets, you can see the green ones are public and the blue ones are private. So how many green ones do we have? We have 2 that are public. How many blue ones do we have? We have 2, and they're going to be private. How many route tables are being created? Wow, we have 3. So we have 4 subnets, but 3 route tables? Why is that? I love being able to hover over these resources, and you're going to see just how it can already start to explain some relationships to answer these questions. If you were to hover over that top route table, you're going to see, a single route table called public is associated with both all of the public subnets. But then each of the private subnets have their own route table. Isn't that cool? Isn't that interesting to see that public subnets can share route tables, but ideally the private subnets have their own route tables. So that's a big learning there. Is there an internet gateway being created? Let's look at the network connection section, and yes, there is an internet gateway. IGW stands for Internet Gateway. Awesome. So as you can imagine, resource maps are so helpful for you to understand the relationships between your components just at a glance. And look, our resource map might look a little straightforward. You might be like, oh yeah, I already know all this off by heart. Like, I don't really need a map to tell me all this. But imagine really, really complicated VPCs. Fun fact, a VPC can have up to 200 subnets. We have 4 in this map. Imagine VPCs with 200. How useful would it be to have a map that automatically highlights the relationships between each of those subnets and other components in your VPC? So again, this is kind of like an example of more complicated setups. And yeah, just look at that. Already this looks way more complicated than what we already have in this little preview here. So you can just see the usefulness of a map also growing with the size of a VPC as well. Not to say that this isn't already useful. This is already extremely useful to start to almost like validate your learnings about how all of these components are linked together. It's like validation from AWS that the links that you've been setting up manually or what you've been creating manually absolutely is how AWS would be setting it up themselves. Okay, very cool. So with that done, let's take a screenshot of that VPC resource map. So let's take a screenshot like this. And let's drag that over into the little click to upload box. And when that's uploaded, click done. Nice. And scroll back to the left-hand side of the screen. And you're going to see that there's a field called name tag auto generation. We're going to say network over here. And do you see, oh my gosh, that was so fast. Look at that. I typed network and look at what's happening on the right-hand side of the console page. Do you see how the name of all of the resources that I'm creating automatically update? Now everything, all the resources already have network. Oh, a poorly spelled network. Let us fix our spelling here. All of these resources already have network at the start. So it's kind of like just setting a tag or setting a name, a naming system for all of the resources that's going to be deployed at the same time. And then for the CIDR block, it's already pre-filled to 10.0.0.0/16, so let's just keep it that way. We don't really need to change it. And you might be thinking, hold on a second. We're creating a new VPC and you're telling me it's going to have the exact same CIDR block as my network VPC? They already have this, the network VPC already has a CIDR block. Last time I wanted to create a subnet with the same CIDR block, I was completely not allowed to do that. So why are we doing this now? So actually, you can have multiple VPCs with the exact same CIDR block. It's just that for subnets within the same VPC can't have the same CIDR blocks. But entire countries, subnets are neighborhoods, sorry. So neighborhoods within your city can't have the same CIDR block, but entire cities, entire VPCs, they can have the same CIDR block. And what this is really saying is VPCs on its own, they're already so isolated from each other that there's no need for them to have different IPv4 CIDR blocks, because you're basically saying, oh, you live in like this whole other country. It is completely okay if your set of addresses is the exact same naming system, exact same everything as another country. It's fine because people are already going to be very clear that like, I'm going to be in a different country. Whatever address here can't possibly be the exact same house as an address that's in a completely different country. The reason why we couldn't have overlapping CIDR blocks within a VPC between subnets is because that distinction or that isolation doesn't exist between our subnets. Subnets just live in the same city, live in the same VPC, and having the same CIDR block could absolutely cause confusion around, oh, okay, so what is your address? Do you belong in this subnet or this subnet? Whereas for VPCs, this isolation already exists. Entire countries or entire cities absolutely would be separated from each other. So it's actually okay for them to have the same CIDR block. Now, just because they can have the same CIDR block doesn't really mean that they should. It is possible, but setting up the same CIDR block means that your overlapping VPCs can't talk to each other directly. This is not going to impact us now, but it's going to impact us later on in this series. You're going to see that it's going to be very, very hard for your VPCs to communicate with each other, for two cities to be communicating with each other if they have the exact same CIDR block. Andre says, hello, what is the name of the gateway? Is this a shared gateway by other VPCs? No, not exactly. So the name of the gateway that we were talking about in this map is called the Internet Gateway, and you can learn more about Internet Gateways from our very first project in this series, IGW. You can also learn more about Internet Gateways earlier in this project itself, but if you have any other questions, let us know. So the name of the Internet Gateway is literally called Network IGW. So the name of all of the resources that's being created is literally the name of like these rectangles that's on this diagram. Cool, I hope that's clear, Andre. Let me know if I didn't quite get your question correctly, because we can absolutely talk about that even more. Sorry about that, team. I think I actually left the Crane VPC page, but we can zoom through this and quickly get back to speed. Here we are now. And let's talk about the next point. So we're going to leave the IPv6 CIDR block option to no, and then we're going to leave the tenancy to default. And both of these are absolutely default settings that you can just leave like this if you have no special requirements. But IPv6 is what you'll need if you absolutely have a requirement to connect to other resources that are using IPv6 and need to recognize resources that are using this system. IPv6 is just like IPv4, but bigger. You can think of it as another way to address resources in a network, except IPv6 has about 340 undecimillion addresses, whereas IPv4 has 4.3 billion possible addresses. So you can think of IPv4 as kind of like a smaller addressing system. IPv6 is massive. It's just huge. It is not as common as IPv4 yet. So tenancy is another concept that relates to resources and your network. In short, tenancy refers to the type of hardware your instances will run on and whether or not that hardware is going to be shared with other customers. And you would only care about tenancy, you would only switch away from the default if you have if you're launching a VPC that's about extremely confidential data or data where you have to comply with like local compliance rules. As you might imagine, most people are going to stick with default. The only people that are going to be sticking with dedicated are like the companies with very extreme strict data protection rules, or they have laws in the country that kind of say like you have to use a dedicated tenancy. Because dedicated tenancy is basically saying your instances will run on hardware that's dedicated to you only. For example, like healthcare companies are likely to use dedicated tenancies. Very big like finance companies might use dedicated tenancies, so their own hardware that the instances will be running on. And this is really a connection between cloud computing and the physical servers now. Because if you're wondering, running on a hardware, what do you mean by hardware? At the end of the day, cloud computing, although an EC2 instance is like virtual to us, what's really happening is a server in the availability zone that you're launching your EC2 instances, that you're launching an EC2 instance in. That server in that availability zone is a server that is truly like running and creating that EC2 instance that's virtual to you, but is physical to the physical server that's in that availability zone. So again, right now, when we're launching an EC2 instance, we're saying that's a virtual machine. We don't actually have a physical computer in front of us when we launch an EC2 instance. But really, what's happening is in the availability zone of the region that you're in, the availability zone is made up of a cluster of data centers. And in that data center, a specific server is creating that EC2 instance for you. And when we choose tenancy, we're saying that specific server that's creating that EC2 instance for me, am I okay with that exact server also creating other EC2 instances, creating other people's resources, or do I want to make sure that specific server is dedicated to me only? Only my resources can be in that server. And again, tenancy is just really for privacy and compliance reasons. Not many people will be fussed about whether or not that physical server is being shared with other customers, but they definitely will be. They definitely would be like fussed about it if they have very strict privacy or security rules to follow. Okay, so that's tenancy ticked off in your learning list. Absolutely, this is something that also comes through in the AWS Cloud Practitioner exam. So I hope that helps. And next thing is the number of availability zones. And we're just going to leave that default value. But the cool thing is knowing that you can actually customize which availability zone within that region you want to provision your subnets in. So cool, eh? So even after you pick two, you can even pick which two availability zones. So that's very handy. And for this one, notice that the number of public subnets is 2, 0 or 2. You can't even pick one. And the reason for that is really AWS's best practice when it comes to networking. So when you pick 2 availability zones, the wizard, make sure you will have a public subnet in each one. You see how you're in 2 availability zones? That means your VPC will have a presence in 2 different clusters of data centers in the region that you're in. And what's really happening here is it's saying, well, you're going to make sure that if you're going to have any public subnets at all, there needs to be at least one public subnet in each cluster, in each data center cluster in your region, in each availability zone. What if the number of availability zones goes to 3? Aha! Now the number of public subnets has to be between either 0 or it's 3. Either you have no public subnets at all in your VPC, or you have 3 public subnets, 1 for each availability zone at minimum. So if I were to click 1, what's it going to do? It's going to say 0 or 1 public subnets, because best practice is you need to have at least 1 public subnet in each of the availability zones you're in, either that or just have no public subnets at all. So that's why, by default, it becomes 2 public subnets. Private subnets have the exact same logic to it. You will see that there's like 0, 2, or 4. And if you click 3, 0, 3, or 6 private subnets. Look at that. Look at the map for that, by the way. Wow. Huge. And it's for the exact same reasons. It's for the exact same reasons, except that with private subnets, it's usually very common to have more private subnets than there are public, which is why AWS is a bit more lenient here and saying like, oh, you can have up to 6, private subnets in this case. Or, if you were to go back to that 2 availability zone thing, you can have up to 4. So 2 private subnets in each. 2 private subnets in each VPC. Oh, sorry. Oh my gosh, I suddenly got tongue-tied there. 2 private subnets in each availability zone that your VPC is going to be like related to. Oh, sorry about that. I totally short-circuited there. Awesome. So here you can also say, here you can also learn about this concept called availability, high availability, or it's also called redundancy. So again, the reason why this kind of limit or this kind of rule exists is to make sure that at least there's 1 in each availability zone. And the reason why we'd want at least one is so that if one of your availability zones go down, the other ones can take cover and take care of your application and make sure it's still running, make sure that nothing breaks for your end users. And that's kind of like the concept of high availability. And having backups in different places is just such a good practice. Imagine if like a natural disaster happens in an availability zone and the entire availability zone like burns down. All of the things that are stored in that availability zone gone. Just completely vanished because of the natural disaster. So if that happens, you're going to want to have backups that exist that can keep you running like nothing's ever happened, and it's kind of like redundancy. And for those reasons, for those best practices or those principles, that's the reason why if you were to have two availability zones for your VPC, then AWS is to create these limits for you. So I hope that helps. And let us play around and select that. Make a little change. Let's make a little change to the 4 private subnets here, and just watch this update itself. And you can see that the route tables update themselves as well. So again, even with 6 subnets, you would still only have 1 route table for all of the public subnets and still 1 route table for each of the private ones. So it's really fun to honestly click around these buttons. I'd highly recommend you do that and just click around like these little different configurations that you could have so that you can really see like the different ways that each of your components in your VPC could connect with each other. It's so fun to see. I love like in a side note, I love that in a setup where you only have private resources, private subnets, notice how the internet gateway goes away. No internet gateway gets set up because internet gateways are only relevant to public subnets. So if you're just launching private subnets, why would you need an internet gateway? And that's why it just gets taken off from the network connections list. Love that little bonus. All right, so we're about to reach the end of this VPC setup flow. And the last thing that I thought would be really cool for us to just learn about are NAT gateways and VPC endpoints. Oh, cool. We're going to take a screenshot for the VPC setup page, and then we're going to talk about these two. So let us take a screenshot of the VPC setup page like this. I think this looks decent. I think this looks pretty good. And let's drag that screenshot over so we can tick this validation, tick this box as well. I love clicking done and seeing that green background. It's just so satisfying. What do you think of it? Okay, so cool. So we're gonna learn about NAT gateways here. And I just realized there was another step we actually skipped. My bad team. The little step I skipped for us that we're going to come back to right now is customizing the subnets CIDR blocks. So cool that just like how you can customize exactly which availability zone your VPC is going to be in, if you have subnets set up, you can directly customize what kind of CIDR block these subnets will have. Customize that directly. So cool. Since this step is all about kind of replicating your work for your Network VPC and automating that, we're just going to try use the exact same CIDR block settings that we've used for Network VPC and bring that over here to that new VPC. So remember how your public subnet has that CIDR block of 10.0.0.0/24? We're going to use the same one here. And same for the private subnet. We're just going to use the same one, 10.0.1.0/24. Oh. So we're going to put that here. Nice. Just like that, it's going to create 2 subnets for us with different CIDR blocks. So handy. Okay. So for the NAT gateways and the VPC endpoints that we were about to get into, and we're going to do that now, we won't get to learn about NAT gateways or use NAT gateways in this project series because they cost money. That's why there's a little $ here. But in short, just know that NAT gateways are how your private subnet, private, not public, are how your private subnet can still get access to the internet, can still connect to the internet without being accessible by the internet. So it's kind of like saying a NAT gateway is going to allow outbound traffic going from your private server or your private subnet to the internet, but it's not going to let any traffic from the internet get to your private server, get to your private subnet. Super, super useful tool. And it's going to be very useful in scenarios where you really want to keep a resource private, but sometimes that resource is going to need access to something that's in the internet because it needs to pull like the latest update from something that's on the internet. It needs to make the latest changes, and by making the latest changes, it needs to again like pull in something that's from the public internet. So NAT gateways are really helpful in that kind of scenario when something in your private subnet actually needs access to the internet. But in the meantime, we're not really going to use NAT gateways, and they cost money, so we're going to click on none. And with the VPC endpoints option, we're also going to select none here because we don't need them. We haven't learned about endpoints yet. We're going to learn about them later in the series. But in the meantime, we're just going to select none. And in short, VPC endpoints are basically how your subnet or resources in your subnet can get access to some of the other AWS services in your AWS account, like S3, directly from the VPC. The reason why VPC endpoints exist is without VPC endpoints, some of your AWS services, like S3, for example, S3 is the big one, can only be accessed through the internet. So what that means is when you're launching an S3 bucket, that bucket doesn't actually sit in your VPC, or getting access to that is an internal, like local communication. It's actually through the internet. Your S3 actually gets launched into the public internet kind of space instead of the VPC. It's a bit of a rabbit hole trying to go into like, why is it in the internet? How do you make that differentiation? We're going to save a lot of that discussion for a later project in the series. And that's your teaser for now for VPC endpoints. But if you're absolutely curious, you can totally read this explanation as well. Okay, so VPC endpoints, none. NAT gateways, none. DNS options, we can leave it checked. It's fine. It doesn't affect us too much. And really, DNS host names are basically human readable names to give to your EC2 instances. So at the moment in EC2 instance, like their default names would be very, very random. It can feel very random because it's just their IP address. But then a DNS host name is basically saying for every EC2 instance that I launch in my subnet, we're going to give them a very human readable name like Denzel Network.compute-1 instead of like a random set of numbers, at the start here. So a very, very simple thing. If you've done the AWS IAM security project, it's very, very similar to having like an account alias, but this time for EC2 instances. And same thing for the other way around for DNS resolution. It's basically saying if you have this ticked, any kind of translating needed between an IP address to a host name will be taken care of by AWS. Anyway, with that all being said, I think we can actually create our VPC now. Wow, let's create it. So let's select create VPC and let's watch it run super fast. Excellent stuff. So our VPC is now created. Let's give it a look. So once you click on view VPC, there's a resource map that still stays, that still gives you that visual look or that visual explanation on how your VPC's components are connected together. So, you can hover over the public subnet that you've created, and you're going to see that it has an association to the public route table that you've set up, and that public route table that you've set up has an association to the internet gateway that it's created as well. So, so satisfying, isn't it? You can even click on some resources to highlight it even more and even review some little bits of information like, oh, this is one subnet association and this route table has 2 routes. So cool, eh? You can also click the same for subnets and see a little bit of information immediately as well. For a subnet, you immediately get to see the CIDR block that it has. Also, it has no IPv6 address. Exactly how he said it. Yeah, your network VPC, you can click on that and it takes you to your VPC immediately. So this resource map is almost like a cheat sheet for how your VPC works. It's so, so handy, isn't it? And yeah, notice how all of the resources have network at the start of the name. That is literally how your name tag auto generation works. Good to see that it's working. All right. So did you know that if you were to select, your new VPC, you can see that resource map that we've talked about? You can also do that for the network VPC you've set up at the very start of this project. So if you click on network VPC, the one that you've created at the start of this project, click on resource map. My goodness, you can actually see all of the connections between the resources you've manually set up one by one happen right here as well. So handy, eh? So lots of love for resource maps, lots of love for this handy new flow for creating VPCs. It's just such a time saver, and it's such a visual way to understand your VPC as well. All right, so with that done, let us answer a few questions. How did you set up your new VPC? I use an alternative way to set up an Amazon VPC. Very true. This time, what did you do this time? This time, I used the VPC and more option, which gives me a VPC resource map to use when creating the VPC and all of its components. E.g., network ACLs, secure, oh no, actually not network ACLs, I was meaning security groups. And route tables. Internet gateways. Shall we just add that in? Yeah, let's just add that in. Cool. Done. Okay, next. What is a VPC resource map? Oh, I feel like... Nah, it's okay. I don't think I'm repeating myself too much. So I'm gonna write a different kind of style for this explanation. A VPC resource map is a visual diagram that maps out my VPC's components / resources. I would say I like the word components a bit more, so I'm gonna use that. That maps out my VPC's components and the relationships, connections between them. A resource map is interactive, i.e., it will highlight the resources, the connections relevant to a resource that I highlight. Hover over. That works too. So that's awesome. And let us click next and check out why can your new VPC have the same IPv4 CIDR block as network VPC. This one's a really good one, and this is something that we addressed at the start of this step, so I hope you still have a bit of an inkling around the reason for this. Let's talk about it. So my new VPC has a CIDR block of 10.0.0.0/16. It is possible for my new VPC to have the exact same IPv4 CIDR block as my existing VPC, network VPC, because VPCs are already isolated from each other. And also, still, this is not best practice, especially, oh, I think I'm gonna break the character count. Still, this is not best practice if we need VPC peering. So that's gonna be something we learn about in the next project, or maybe 2 projects next in the series. VPC peering, which is basically how your VPCs can talk to each other. How many public subnets could you create? When determining the number of public subnets in my VPC, I only had 2 options. This is because, some great prompts. Okay, so we can say here, when determining the number of public subnets in my VPC, I only had 2 options. Either none or one in each availability zone for my VPC. This was because it is best practice, or in brackets, improves redundancy and high availability. This is because it is best practice, or improves redundancy and high availability, to have at least one subnet per availability zone. Great. If you're wondering why I've made this part of the answer so short, it's because I only had 2 characters left. Damn. But I'm really glad that this answer is filled out, and let's move on to the next one. What are NAT gateways? Oh, this is good. We didn't get to learn about these in detail because we don't get to create NAT gateways, but we've learned that the setup page also offered to create NAT gateways, which are connectors, gateways that will let resources in my private subnet get access to the internet while still blocking off incoming traffic from the internet. Get access to the internet, e.g., for example, for security updates. So handy, NAT gateways. It's really, really cool to know, for example, that a huge benefit of having NAT gateways is that it also protects your resources, the specific resources in the subnet, because how internet gateways work is it requires that public IPv4 address for every single resource in the subnet. But in the case of NAT gateways, you don't need a public IPv4 address for your resources in the subnet anymore. The resources in your subnet can still stay private with their private IPv4 address, but then the NAT gateway is going to translate or do some sort of magic to the IP address and help it connect to the internet by almost being that ghost that almost acts as a public IPv4 address on behalf of your private resource. So I highly recommend just searching up NAT Gateway and learning a little bit more on how they work, because they're extremely useful, they're extremely practical, and just a great resource to know about if you have a private subnet going. But cool, hope you learned something new on that quick definition or that quick learning piece on NAT gateways though. All right, done. Okay, so if you like, you can take 30 seconds to just visit each of those subpages to verify that some of the VPC's components have already been created for you. If you click on subnets and refresh the page, look at that beauty. A private subnet and a public subnet has been created for you. And you can do the same with the route tables, refresh this, look at that. Network RTP public has been created, same as the private one. Internet gateways, look at that. Network IGW has been created for you already. Scroll down, security groups. Look at that. There's already been a security group created for you. And it would be very hard to recognize it up front. But let's click refresh. Let's click refresh, and you should be able to see a security group as well. Yeah, so this is like the default security group for, oh, you almost can't see it. Sorry, I'm just like trying to make sure that we miss it, but I think we have it. So if you were to look at your security groups, you can see that there are different security groups on this page, and then you can click on details and then click on the VPC ID to try track down which VPC a security group is relevant to. Okay, it seems like we can't seem to see the security group for this one, which makes me a little bit surprised. I'm like, where did it go? Hello, security group. Here you are. We found it. Oh, that was good. So we found the security group that is linked with our new VPC. If you were to scroll here and look at VPC ID, click into the VPC ID until you find the one that says, oh yeah, this route table is associated with the new VPC that you've just created. So awesome. We've even secured that too. Oh, Milia says, hi, I'm already almost sleeping. Just pop in to say hi and wish all the best. Thank you so much, Milia. That's so sweet. Thank you for thinking of us, popping in and saying hi. Super, super sweet of you. We're so blessed. Thank you so much. So yeah, as you can see, a lot of these. Oh, it's Uliana here from another account. Oh, thank you, Uliana. Oh my goodness. Yeah, you must be sleepy. It is quite late over here in New Zealand. Take care. Hope you have a good night. Thank you again for popping in and saying hi. That really makes our night. So thank you so much. And yes, as you can see, network ACLs, same thing. There's already a network ACL, set up by default already for your new VPC, Nextweek VPC. And it's already by default associated with the two subnets, your public and the private subnet, that you've set up as well. Very cool. So nice work, all done for today. You've just completed today's project. You've set up your very own VPC with the private and public resources. So high fives all around. All done. Congratulations. And let us wrap up with a few final questions. What is Amazon VPC and why is it useful? Amazon VPC is AWS's foundational networking service that helps us create our own networks and configure the security, traffic rules, and connectivity with the internet. So many things that you can do with a VPC. It is wild. It is madness. And how did you use Amazon VPC in today's project? So we used Amazon VPC today. You can talk in first person for your own documentation. I used Amazon VPC to create my own VPC with its resources. Shout out to people in the chat. Maximus saying you are the best net. Thank you so much, Maximus. Joe Chang saying woo. Ooh, Andre saying by using an egress-only internet gateway, I guess we can achieve the same thing as a net gateway without paying more. Yeah, I think it's a very good point. And I think Andre, with an internet gateway, at the end of the day, the fact that it can allow inbound traffic from the internet makes it not the same as a net gateway in the first place. Like even if you remove, I think even if you remove like a few settings, the fact that internet gateways like have that ability to allow in like inbound traffic makes like a net gateway a lot more ideal. Although I must say I do need to do a little bit more research on egress only internet gateways myself to fully understand how that compares with a net gateway. Um, very very good point. I think something for us to research on our own as well. Thanks for the tip by the way, Andre. Really really love that. And all right, so I used Amazon VPC to create my own VPC with um, different resources, components, e.g. security groups, or network ACLs, for example, and private resources, e.g. a private subnet, and EC2 instances in both my public and private subnets. We did a lot in this project, by the way. My goodness, what is one thing you didn't expect? I didn't expect the resource map to be so visual and interactive. Such a convenient and speedy way to set up an entire VPC architecture. It truly is. I love it. How much time did this project take you? Ooh, this project took me 2.5 hours to complete, including live demo time. Done. Very nice. All done. Okay. Now that we have finished kind of like the wrap up, the reflection for this, how do I say this? For this project, we're gonna see documentation come through at the end. It's gonna be very, very cool to see. In the meantime, though, we're just gonna make sure that we delete our resources. Deleting the resources, so easy. All you have to do is select your VPCs and in the actions, try to delete them. Ooh, you can't delete them automatically right now. Let's see why. Your VPC can't be deleted because it contains one or more instances. So we still need to delete the instances first. Let's head to our EC2 instance console and let's delete them. So let's select the private server and the public server that we created today. And under Manage Instance State, we're just going to make sure we select Terminate and change the state. All done. Terminate them. I'm going to delete them. I'm going to cleanse them out of our account. Make sure we don't get charged. It is okay to delete your resources. We got to let go sometimes. As tempting as it is to keep your resources, to be like, oh, but what if I need to come back to this? It is a lot better to just delete them and know that you can just create new ones if you ever need it. Same with network interfaces, we can just delete those as well. So let's select the network interfaces for both our EC2 instances, and under Actions, let's select Delete. Oh, it's currently in use, so these instances still need to be deleted. It's still being shut down until we can delete that network interface. If you're new to the concept of a network interface, by the way, just know that you know how an internet gateway has two arms? One arm is touching the VPC, one arm is touching the public internet. A network interface plays a similar role, but between your interface, between your EC2 instance and the your VPC. So you can think of it as that little connector that makes sure that your EC2 instance is connected with your VPC. That's what a network interface does. It works at the instance level, and that's why we have two. One for our public server and one for the private server. So I'm just gonna refresh the page for our instances. It's terminated now. So our EC2 instances are off of our account now. We want that. And because it's off of our account now, we should be able to delete the network interfaces. So let's try click delete. Oh, if you don't see that happening, let's just refresh. Oh, the network interface has already been deleted. So good. So as you can see here, sometimes your network interface just gets deleted automatically. It should always delete automatically with your EC2 instance. But sometimes if your VPC page says that it still contains one or more, either it is still waiting for them to be automatically deleted. Usually that's the case. Or sometimes it's just a little bug that requires you to manually delete it yourself. That happens a bit rarely, but it can happen sometimes. If it does, don't be scared. Just go in and delete the network interface for yourself. In my case, as you can see, it just deleted automatically with the EC2 instance almost instantly. So that was a time saver. Thank you, AWS, for doing that for me. And because those resources are terminated now, I can actually safely delete my VPC and look at to go. It's deleting it. Wow, Joe says safer for your wallet as well to delete the resources, especially if you're forgetful like me. I vibe with that so hard, Joe. I honestly can't. It's going to be embarrassing for me to admit just how many times I have actually left resources in my account without knowing. And then only realizing when I log into my AWS account again, and I'm like, oh my gosh, why is my monthly cost forecast, why is it not $0? And then realizing, I left the resource running, didn't I? All right. Make sure you delete the other VPC you've set up using the automatic flow or that VPC resource map. Make sure you delete that second VPC. And I think just like that, we're all done for today. You know, all of your subnets, as usual, will get deleted. Same with the route tables. Same with the internet gateways. Just click on the refresh button each time, and you can see it just update. Like, oh, it's already been deleted. They're already gone. So handy. Just saves you a lot of time. And yeah, just like that, you're ready to share your project. So this is where you're gonna see your project documentation. And thank you so much, King of Zamunda, for saying thank you, Natasha. It is always a great learning session. Thank you so much, King of Zamunda. It's always a good vibe to have you. Happy birthday as well. Thank you, King of Zamunda. Andre says, thank you, nice channel. Goodbye. See ya, Andres. Hope to see you in the next one. Thanks for checking out the channel. Hope to see you in the next one community as well. Hey, let's hang out there. Okay, so you're gonna see that this is a completely new way to share your project. It's very exciting. All you have to do is scroll to the very bottom. Did you see how at the start of this project it was gray? Now it's blue because we've ticked done for all of this, all of the questions and also all the screenshots. And when you click on mission accomplished, great job! So this is the next week team. The entire team's over here. So much love for each and every one of the members of the team. And yeah, you can share your project on LinkedIn. You can also view the documentation. What we're going to do first is we're going to view the documentation first. Let's click on that. Wow, all of the screenshots I've added, all of the text that I've inputted, all organized so neatly in a documentation template for me. There's even headings. It's exactly the text that I put in, exactly the screenshots that I've put in, and it looks really neat. Oop, I'm just gonna make sure you can see the complete thing by zooming out a little bit. Yeah, it looks really clean. Everything is well organized for you. If you have any requests with this automatic documentation generator, add them to the chat right now, or you can comment it if you're watching it after this live. Would love to see what you think about this automatic document generator. Literally, you don't even need to lift a finger anymore. Like, all of this stuff has already been put in there for you. But is there anything else that you'd like to see? We'd love to know. All you have to do once you have opened your document is you can click that blue bar at the top, and that's going to automatically open this page that helps you download your documentation as a PDF. Now, when I'm downloading my documentation as a PDF, I am going to make sure that I have selected the option to save it as a PDF, and also I'm going to make sure that I have unchecked the option headers and footers. I realize that your screen has cut off a little bit of what I'm seeing, so I'm gonna switch this tab back here to show you the screenshot. Make sure that when you have opened this panel, over here you're selecting Save as PDF under Destination. And then you're going to click on more settings, which is this little arrow here. And you are going to make sure, please do this for yourself, uncheck the headers and footers option so that when you download your PDF, it is a clean, super clean style. And if you see that your documentation is kind of like being cut off, or you have photos that's kind of like just hanging at the bottom of your page, the reason for that is probably the paper size is an A4. This documentation looks best if the paper size that you've selected under more settings is A4, the pages per sheet is 1, the margins are default, make sure it's in portrait, not landscape. Layout here should be portrait, not landscape, and that's going to make sure that you're downloading your documentation in the best way possible. So do that for yourself. And once you've downloaded it, I'm going to save this documentation. It looks so good. Add your name to it, when you download it. And once that's done, you can also come back to this panel and click on that Share on LinkedIn button. Click on that. Share on LinkedIn. Beautiful stuff. There's already a LinkedIn post that's populated for me that can help me share my work. You will absolutely have the exact same copy. So if you're wondering, oh my god, I want this LinkedIn post copy, you will absolutely have that when you click on that button too. And all you have to do is click on that little X button on this corner here to close that little preview so that you can attach your documentation. So click on that plus button at the bottom of the panel, click on the add a document icon, and then choose a file. Of course, choose your documentation. So click on the PDF that you've downloaded. You can even add a little title to it. Just copy that title that's already in there. That works honestly perfectly fine. And then you can click done and then upload and then post right away. So click on done like this. And actually before you post right away, you're just gonna make sure that you highlight the add to Nextwork here. Just double click on Nextwork's name, or you can add a little @ in front of Nextwork and click on Nextwork so you can tag us. And once that tag is done, your post is going to be pushed out to so many more people than if that tag wasn't there. Because tagging @Nextwork is going to push you out to other fellow community members that follow Nextwork. It's going to push it out to the Nextwork team. It's going to push it out to other people that are also in the Nextwork community or already have Nextwork posts on their feed. It just grows and grows and grows and grows. Make sure you tag. It's great for yourself. It's also great for us to see more people trying out a new project. And then click post and you're done. So thank you so much for joining me in today's project. It has been so productive. Thank you so much, Wendy, for saying awesome. Thank you, Dylan, for saying learned a lot today. Thanks, Nat. That is super sweet. Thank you so much. And look at you go, because that is networking project 4 done. You have created this entire setup in this project. This entire setup, you did that. And you've learned how to launch a public EC2 instance. You've learned how to launch a private EC2 instance. You've learned how to launch your VPC setup in just minutes with that resource map. You've done so much. You should be absolutely proud of yourself. And it is just so wild that all these learnings are packed in a single project. In that one single session, you've learned all of this, and it's going to go so far. We can't wait to see you in that very next networking project in this series, because we're going to keep on building on this. This is not the end. And there's just so much more cool stuff to come. I just realized by hitting the end of this 4th project, you've officially hit the halfway mark for this entire series. So lots more cool learnings to come, and there's already lots more cool learnings that's happened. Okay. We're gonna have to end it here now. Thank you so much, Joe, for the shout out. Super great vibes as always. Super great vibes as always, Joe. Thank you so much. I need to get some shut eye now. Very good idea. Good night to you, Joe. And hope everyone that's tuning in from wherever they are, whatever time it is for you over there, that you have a great day. Great work again. Congratulations on making it to the end of this project. Let's stay in touch in the community, and we'll see you in the next project. It's going to be super exciting. All right, now. It's always so sad when I finish a live, my goodness. But we will see each other next week again, okay? So see you then. Bye for now. Bye.